This conference will now be recorded. This conference will now be recorded.
Right. In the last session, we were discussing about list data structure and its operations. And now today I'm going to discuss about tuple data structure and its operations. So as I told you that tuple is uh, same as list. It is ordered collection of items, but only the difference is between tuple and list. List is mutable, and whereas tuple is immutable. Once we create a tuple, we cannot modify the tuple here. So tuple is also same as list. It is ordered collection of items. Tuple can be created by using round brackets, or else without bracket also we can able to create tuple. And creating tuple with one element is somewhat different. I will show you how to create tuple with one element. First, let me create tuple with a few elements. And tuple is contain different data type items. Yes, in the tuple items, any data type item we can able to place, and tuple is accept duplicate items also. No problem at all. That is duplicate items also accept. It is not unique items. So for example, tuple, I'm creating 10, 20, and a tuple item is one string item. I'm taking A, then 23.4. It is float item. Then next, what we can say, there's some name I'm taking. Different data type items are there with tuple. So print tuple, print tuple. Let's execute. Tuple is clearly printed. Now print type of tuple. Type of tuple. So tuple type is here. It is tuple. So without bracket also, it's possible to create a tuple. So no need to give bracket. So automatically it is tuple creation possible. So brackets are optional here while creating tuple. Now tuple creating tuple with one element is different. So look at here, TPL equals to, I'm creating tuple with one element with bracket or without bracket, but it is not treated as what it is tuple. It's just for integer actually here because we have given only one number. So otherwise you can give some any name. So that data type is written. You can see this. This is string actually string. So this is string. Whatever we have given one element, that element data type only written. So now you can see SAI this time. So comma I'm giving no. It's treated as tuple. So after creating one element, after element we have to provide comma, then only it will be considered as a tuple. So creating tuple with one element is bit different. After element, you must and should give comma symbol. Otherwise, it written as data type of the value, not tuple value. Okay. Accessing elements from the tuple is same as list. To access elements from tuple, we can use indexes. So negative index, positive index is possible. So how to access elements from tuple 10, 20, 30, 40, 50. These are the tuple elements. Print TPL, then print TPL of 1. 1 means index actually. So 1 index, what item is there? 20 item is there. So minus 1, if I take, what happened? Minus 1. So minus 1 in the sense, this is 50. Yes, minus 1. Negative index will come from right to left. No? Suppose tuple slicing is possible, 2 to 5. 2 to 5 in the sense, 0, 1, 2, 3, 4. 5 is there? No. But still it is working or not? Yes. 30, 40, 50 is there. 5 means up to 5, not including 5. So that's what 2 index onwards. 2, 3, 4, 0, 1, 2, 3, 4. 4 means up, 4 index last. Here I have given 5, no? Even 5 I have given. What happened? Up to 5, no? It will not be considered. So that's what up to 5 means 4 only consider. Now you can see the 6 only here I'm giving, no. So even whatever the elements are there, its ending index is not matter, it is. So you can give that last element up to it is going to be read. So no error is coming, index out of range, nothing will be there. Only the thing is, without slicing, I'm giving 6 or 8 index. Now you can see 8 index, it is index out of range only, because 8 index is not there. But in the range of starting index is big in, no, starting index, but sixth index is there. Sixth index do you have? No. So no, sixth index means what? Second index onwards automatically it will be starts. So from where 0 1 2 2 3 4 it will be ended, no elements are there. But here 30 40 50 only will be there, 6 is not there. So that means here we can see this 2 index onwards nothing is given, in the sense invalid, it's not valid actually, or else it is empty. So by default from that index onwards elements will be read. For example, here 5 in the sense starting index I didn't mention. So 0 1 2 3 4 up to 5 in the sense, that is all elements will be written, simple like. Or else up to 4, 0 1 2 3 0 1 2 3, this is slicing. So accessing elements from tuple slicing is like this. Now tuple is immutable. Tuple is immutable means we cannot add, we cannot change the elements into the tuple. Let's see the practically how it is immutable, whether it is accept or not. Generally, we have a tuple. I want to add some element to the tuple. TPL of 1. In one index, I want to add 33. Print TPL. Print TPL. So 33 item I am adding. Now you can see tuple object does not support item assignment. Tuple object does not support item assignment. Item assignment is not possible in the tuple case. Okay, why? Because uh, we are not, it is not possible to modify that. It is not possible to modify that. That's what I'm saying. Tuple is immutable. We can say that. Item assignment is not possible means we cannot able to add into the tuple. Tuple is immutable. Whereas if it is list, item assignment is possible. Yes, we can assign the item into the list, but we cannot assign any item into the tuple. It's not possible. So this is tuple is immutable nature. So tuple concatenation and multiplication, that is very simple. So adding two or more tuples into single tuple is called tuple concatenation. Repeatedly one tuple you want to display number of times, that is called tuple multiplication, we can say that. For example, TPL1, my tuple is like this. I'm not using any bracket. Now TPL2, it's my tuple. Print TPL1 plus TPL2. Now you can see both tuples are added or not. Yes. One of the tuple we want to print repeatedly, TPL1 into 2 times I want to print tuple 1. So it's repeatedly printed here. Tuple 1 2 times has been printed. Okay. So this is tuple concatenation and multiplication. It's very simple. Already we discussed in the many data structure like list concatenation, string concatenation, like this. Now coming to the point, deleting a tuple. Again, one more doubt here. Tuple is immutable, no? So how it is possible to delete actually here? Yes. So deleting one item, changing one item, adding one item or any other items, it's not possible. But even though tuple is immutable, we can able to delete entire the tuple. Yes, complete tuple we can able to delete. No modification, no deleting single element, no adding multiple elements, nothing. Directly we can able to delete complete items, tuple items. How it is possible? You can see. Suppose tuple is there, print print TPL, print TPL. Click on execute. So tuple is printed. Okay. Next, what I'm saying. mm, I want to delete tuple. To delete tuple, we use del keyword, del keyword. After deleting also, I'm trying to get tuple actually, print TPL. Is it possible? Nothing. It's not possible. Name TPL is not defined. That means Once we delete a tuple, so it is not going to be print again. So you're trying to access that tuple, it's not there because tuple was deleted completely. So deleting tuple is possible here. Next, tuple methods also. Tuple is having few methods only, because we don't have any what we can say modification support. So that's what we have less methods in this. Only count and index methods. Few methods again are there. Count and index. How it is possible to count an item into the tuple, and suppose particular item index I want to get, then we can use index. Count means if any item is there in the tuple, that item how many number of times repeatedly available in the tuple, that will return by count. Okay, so for example, tpl equals to my tuple is a, like this is my tuple. Printer tpl dot tpl dot count. Suppose item P how many times repeatedly done? Two times. Suppose L, it is one time. So count to method will return number of occurrences of the value from the tuple. So number of occurrences means how many number of times it is there in the tuple, it's written. Whereas index method, index method is used to find the item index. A is there, no? It is available in which index it's going to be found. Index method is used to find the item index. Suppose let's run this, index is 0. 0 index actually it is. 0 index. Okay. So 0 index clearly available. Suppose if I'm giving a repeated item like this, P is there. Here two P's are there. You can see 0, 1, 2. So which index is written? Obviously 1 only. Why? Because first whatever it come, it will be written. This is what one index. Suppose whatever I give, suppose capital P I'm giving, I'll try to do that. This is capital P I have given, but in that case index is small p. So whether it will be find out 1 or 2, yes, observe carefully, 2. Okay, this is capital P I have given, this is small p I have given, but now you can see index of small p I'm trying to get, that is 0, 1, 2. That means 2 index is written. Here also if I'm giving capital P, then now this time what happened? 1 only. So difference is there actually, capital P and small p. But both are uh, not capitals, only small. Then both are equal, no? So obviously first whatever it come, it is going to be written 0, 1. First only it is coming. This is called index. Index method is used to find the item index, in which index the item is present in the tuple. Count method is used to return the count of item, how many number of times present in the tuple. So that is index and count. Now coming to the thing, tuple membership test. Membership test. It's very simple. Membership test means if your element is present in tuple or not, or else one item is there, that item is present in tuple or not, you can able to cross verify. That is called membership test. For example, this is only my tuple. I want to know a in a in TPL in the sense in not in, both are membership test actually, membership operators we discussed in the beginning sessions. Print a in TPL in the sense a is present in TPL, yes it's present, that's what it written true. Suppose d in TPL, no, d is not in tuple, so it written what, completely false. So d's don't have tuple, don't have in the tuple. Suppose I'm going to compare with the not in. D not in TPL. D not in TPL in the sense true. Why? Because D is not at all in TPL. No. Suppose D in TPL means false because D is not there in TPL. So this is what membership test. Membership test is means if your value is present in tuple or not, we can able to cross verify it. So if it is there, in operator will return true. Otherwise false. If it is not there, in operator will not in operator will return true, otherwise false. This is membership test of the tuple. Now there is common methods, length, max, minimum, sum. Length means it is used to find out length of the tuple. How many? Elements are present in the tuple that we can get by using length. Max means maximum number of item we can able to get. Min means minimum number of items. Sum means all items are going to be sum. Okay, so let's try to do that. But is this possible to find out length method here? Yes, it's possible to find out length. How many number of items are there in the tuple? It's clearly possible. 5 items are there. Is this possible to max of tuple? Look at here. Max of tuple is p, highest value, highest ASCII value of the character here. So clearly p is there according to alphabetic. Minimum, is it possible? Minimum. Now you can minimum letter is A. Then sum is possible. Look at here. Sum now this time. So unsupported operand time. So we cannot able to add some string. Okay, string sum is not possible. Sim is a mathematical function actually here. So we can able to find out some operation with the values, for example, 234.5, 6 minus 9. Like this, you can able to find out. Sum of TPL in the sense this is 6.5. There is optional parameter with some operator. You can use your number also. That number through its some operation will be performed. Now let's run this. So 13.5 is available clearly. 7 plus something here. 13.5 totally. So this is tuple methods. Length, it is used to find out number of elements in the tuple, maximum element finding, minimum elements, sum of the elements. So here we can find the maximum elements. Max of tuple, max of tuple means in this maximum element is I think 6. Minimum of tuple minus 9, min minus 9. This is minus 9. Okay, like so next, converting a string into tuple. Yes, this is what some are interest. So you have it string, but I want to convert that into tuple. So how it is possible? First, let me create one string. After that, let's try to convert into tuple form. Okay. So this is string s equals to or else str equals to durso durgasoft I'm using. Okay. This is string. Print string as it is. Print type of str, type of str. This is type of str. Okay, then after that I want to convert this string into tuple. No? Yes, tpl equals to tuple. Tuple is the data type of str. Then print tpl, print tpl. Then print type of tpl, type of tpl. So this time you can see type of tpl. It's completely string actually. First this is string, but here it is converted into tuple form. So we converted a string into tuple clearly. Similarly, we can able to do that converting a list into tuple. Yes, we can create this as a list, lst. So we can create list, any list, not only this 2 3 4 5 list. It is print lst, print type of lst. It is list actually. So I'm converting that into list, tuple of lst. So after list conversion, this is list is available and we converted into what tuple format. Easily we can able to convert from one data type to another data type by mentioning that particular target data type here, tuple tuple. Now converting a tuple into string, yes, we can do that reverse actually. Tuple you have to create and convert that into list actually here. Converting a tuple into list, converting a tuple into string, sorry. So TPL is there, TPL. When we convert string tuple, why it is not coming as a single item tuple? Single item tuple, why? It's coming, no single item tuple. It's not single item tuple, it's a group of characters, no? Your item is string, then it will be converted into tuple. For example, here, A, print, for example, str equals to A, print str, print type of str. It's not convert that item is not only one group of characters, that is string. It's not how we can say one item string is not. Now this time one item I'm taking, no. Now you can say tuple tuple of str, print tpl, then print type of tpl, print type of tpl. Now this time our target is only one item. Now you can see one item is a string, but I have converted into that into tuple. But did you notice that one item creation tuple with different format actually? That's what automatically one item after what was there, comma is there, because tuple creation look like that. To create a tuple with one item, compulsory how to mention comma symbol after the element. It's automatically printed. You can see this tuple structure only. This is converting a tuple into string, list into tuple, converting string into tuple. All are similar actually. Just convert from one data type to another data type. Next, set data structure. We'll see that set is different actually. I'll show you what is set and how to do that. Set is unordered collection of unique items. Unordered means what? Not an ordered. Order is not there, undoubtedly. Set is unordered collection of unique items. Unordered. Creating set, how it is possible? Generally, to create a set, we have to use some flower braces, like curly braces we have to use. Set is unordered collection of unique items. Then set is contain different data type items. Different data type items means we can able to use string data type items, integer data type items, floating data type items. Any data type items is possible, but all items must be unique, not duplicate. Duplicate is not possible in set. Set creation is possible by using curly braces actually. Creating an empty set also possible, but to create an empty set we should not use empty curly braces, because when we use empty curly braces, that will be treated as dictionary. Because in dictionary also we can able to create by using empty curly braces. That's what it treated as dictionary. But to create empty set we use set function actually. How to use set function I'll tell you, just wait. Now I'm going to create set s equals to, or s equals to, so this is, if I'll try to do that, it's not set, because I'm trying to create empty set type of s. It's not possible. See here, it is what? Dictionary, not set. But how to do that creation of set function I have to use. This is normal set. Okay, set. So set with the different data type items, how it is. S equals to 2a 2.36 sai. Okay, this is what different data type element. Print s, print type of s. So this is set is created, but look at this, order is available? No. So it is unordered collection of unique items. Unordered. Order is not important. Order is not going to display. It is completely unordered. But sir, what happened whenever I give duplicate item already which was available to, no? Okay, already which was available A, no? So like this, it will ignore simply. Now you can see this 6 SAI 2.3 A only will be print. How many times you are executing, that many times result may be different. Closely observe here. So every time result is going to be changes. Order is something change might be. So duplicate items if found in the set, automatically that will be ignored. That will be ignored. Okay. This is set creation, creating empty set. How to change set? Set is possible. Set is mutable or immutable? Yes, it is mutable. We can able to modify the set. There are two methods are there. You can see how to change a set means add and update. Add and update. What is the difference between add and update method in the set? Okay, so add means to add only one item into the set. Update means to add multiple item into the set. So add means to add one item. Update means to add multiple items. So how it is possible? Add and update. We'll check out. Add, update. Suppose uh, see here s dot. I'll try to add it. I want add s dot add. I want to add d, then print s. So it is added or not? Yes, d. Sir, where it is added? You cannot specifically, I want to add in one location, I want to add in two locations because it is unordered. Unordered means we don't know where it is going to display it is. So it is completely unordered collection of items. We cannot decide one item should be add like that only. Okay, we cannot do that. So s dot add of d means it's going to be add like this. S dot add of d. D is added actually. Only adding one item, not multiple item. Multiple item is not possible. To add multiple items to the set, we can use what? Update method. Update. So update method using multiple items, we can add it. 3, 5, 6. But look at here. D is not there in existing set. 3 is not there in existing set. 5 is also not there in existing set. 6 is there, no? But still you are adding. Yes, you can see type error. Int object is uniterable. So to add multiple items, I think you have to give compulsory in the square bracket. So now you can see this. We got an output clearly. So, but what happened? This 6 was added? No. Already 6 was there. Only one 6 is there. It was not added. So multiple items you want to add by using update method. Then what we have to do? Square bracket compulsory required to pass multiple items. So items also added, but may not be order, or maybe it's not be order actually. It is completely unordered collection of items. So whatever we have added D, 3, 5, 6, it's not order actually. Somewhere it is D is available, 3 is available here, 5 is available, 6 is not available, 6 is not added because already 6 was there. So this is what update method is used to add multiple items to the set. What we can say insert method, add method is used to add only one item to the set. And you can able to remove the elements from the set also. So you don't want to maintain some elements from the set, we can able to remove that. For removing process, we have two methods are there. One is discard method and remove method. One is discard and another one is remove method. See, remove method, discard method difference is what you can see this. Remove s dot discard, I will show you. Discard, what item you want to remove? Just a. Print, yes. So a is present in the set? Yes. It was present, no? That's what it was deleted from the set. Suppose b I am giving. Do you have any b? No b. So what happened here? See, nothing is written. Remain unchanged. So discard method is remove the item when it is present in the set. If the item is not present in the set, it remain unchanged. That means nothing will be happen. No changes will be effect. Discard method. Suppose here I'm using remove method. Remove method. If item is there, suppose item is there a again, for example, a item is there, then remove method is remove the item. Okay, but here if item is not there, then it return error. You can see this key error it return. So remove method is not remove when the item is not present in the set. If it is not present, then key error will return. Whereas discard method, if the item is not there, it remain unchanged. It don't give any error. So that is remove method, discard method differences. See both methods, if item is there, it will be work fine. Remove method as well as discard method. And only the case is if the item is not present in the set, discard method will not give any error. It remain unchanged. But whereas remove method will give key error if the item is not present in the set. Actually, this is the difference between discard method and remove method in the set. Actually, removing elements from set is, we can use remove method or discard method, any one. How to change set? Adding one item purpose, we can use add method. Adding multiple item purpose, we can use update method. Now coming to the set operations, union is there, intersection, difference, symmetric difference. So what are the set operations? You can see this. These are the two sets I'm taking here. Two sets I'm taking S1 or else A, you can say A. So what we can see, 1, 2, 3, 4, 5. B set I'm taking 4, 5, 6, 7, 8. Now print see A union B. This is what A union B symbol I have given. Union A union B. So union will return what? Unique values from both sets. You can see this unique values from both sets. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 4, 5 here it is there, and here also it is there. But 2 times 4, 5 is came? No, it's only one time. So union will return unique values from both sides. But this is symbol through we did, but you can use function also, union function, union B. A dot union B, it also fine, it's working, both are same. Whereas intersection is there, no? Here in sorry, intersection symbol is and. So what is intersection? What it return intersection? So intersection will return common values present in both tables. Common values are what? 4, 5, 4, 5. Here 4, 5 is there, here 4, 5 is there. Both sets are present in common values, no? That is intersection. Otherwise, without and symbol, we can use intersection function also. Into A dot intersection of B. So we got in same output here. Next, difference is there. Difference means minus. This is somewhat difference. You can see A minus B. If I give A minus B, A minus B, the values which are only from A, not in B. Now print B minus A in the sense the values which are from only B, not in A. So that is 1, 2, 3. The values from only A, 1, 2, 3. Values which are present in B, not. It is not. So here B minus A in the sense the values which are present in only B, which are not available in A, also not there. So that is 4, 5 is available A or not? Yes. So this is 1, 2, 3 from A minus B, 8, 6, 7 from B minus A. So why it is 6, 7, 8 not 7, 6, 8, 6, 7, 8 is because unordered. We cannot go with completely otherwise. So this is this difference. Then symmetric difference is there. Symmetric difference, that is cap symbol. So how it will be? Look at here. Symmetric difference. A cap B. A cap B. So it written completely uh, 1, 2, 3, 6, 7, 8. That means it ignore completely common value. Intersection elements will ignore. Only unique elements. Both are set. Both sets. Whatever the unique elements will be there in both sets, it will return. But which are commonly presented elements are going to be removed completely here. Commonly presented elements, whatever it is there, it remove completely. So 1, 2, 3, 6, 7, 8 is there. So these are the basic set operations in the what you can say union, intersection, difference, symmetric difference. And membership test, membership test is your item is present in the set or not, you can able to find out. So print one in A. Yes, one item is there in A, so that's what it is written true. Suppose one not in A, no, it is not in A, it is false because one is available. 10 not in A, yes, 10 is not in A, true is completely. This is membership test. So as usual, length means you can able to find out length of the given set. How to find length of the given set? I'll show you. Print length of A, length of A. So this is 5 length. Okay, 5 length. Next, maximum minimum sum is common. Max of A. Common methods of both what you can say tuple and all. Maximum element is. Minimum element is what? Minimum is only one. So sum of the elements are sum of A. completely sum of the elements. You can use any number also. Suppose 90 I have given, 105 is the sum actually here. This is what a complete set data structure and its operations what we have. So next we discuss what we can say dictionary. Okay, so dictionary I'll start tomorrow. I'll take tomorrow. I'll discuss complete dictionary about what is dictionary, creating dictionary, accessing elements from dictionary, changing or adding elements. Dictionary is also unordered collection of items completely. Okay, it is somewhat different because in each item in dictionary pair of two things. One is key and value. So that I'll discuss in tomorrow. Dictionary completely. Okay, even if I start, it will not be finished. Okay, yes. So see you tomorrow. Uh, most probably we'll get video by today 10 or 11 in between. Okay, sure. Today I'll try to send. Okay, see you tomorrow at same time 6 a.m. Okay, tomorrow. Yes, yes. Tomorrow we'll complete dictionary. After that we'll move to another topics. Okay, functions topic, important topic we'll discuss. Yeah, Ramesh, I'll share the document. Okay. Yes.